I'm now going to demonstrate what a real Fairlight wavetable program looks like and how it actually operates on a 6-bit DAC, such as on this IMSAI 8080. So what we'll do is go to drive B, and I'll do a directory. And I've written an assembly language program called sample.asm. We can look at it. And what this program does is it goes to address 400 in memory, and for the following 2600F8 hex bytes, it's going to read in the wavetable byte, and it's going to output it to the music board, which is at address 24, using an output statement. It's first masked to FC to take the top 6 bits, because it's an 6-bit DAC, not an 8-bit DAC. The wavetable itself is an 8-bit data. So let's assemble this program. So we'll call A assembler sample The CPM assembler has been called. It's now assembling the machine language. And we will do a load. Sample to take the hex file and create an object code file. Now we can look at these files. We have the actual machine code here in sample.com. We can look at that using a dump command. That's the actual machine language for this program. Alternatively, one can look at the print file. I'm just showing you different ways of looking at the assembled and source code. So here again we have the program as I wrote it on the right side, and on the left side is the actual machine code corresponding to the assembly language statements. So there it is. Now let's look at the actual sampled file. I took a sound of a bell ringing from a telephone, an actual bell ringing sound, and I have that here as a table in bell.com. Now we can actually look at that data. We can use the dynamic debugger actually to look at that. So I'm going to call DDT. And we will input the file bell.com and read it. And the actual data we're interested in starts at hex 400. So we'll do a display 0400. And there it is. And it's about 6,000 bytes long. So all this is the sample of a bell ringing. 6K file. So anyway, I'm going to play this file now. So what we have to do is we've loaded this file into memory. So it's sitting at 400 now, which is great. So we'll exit this. And now we'll start the program sample. Now we have to go and change the sampling rate. And there we have it, a 6-bit DAC creating a very musical bell. And of course, just like a keyboard on a Fairlight, we can change the pitch by changing the timing loop or the clock. All kinds of bells here. So it's a real simulation of a Fairlight, and it's working. So I'm very impressed with a 6-bit DAC doing this.